Fundamentally, everything involves chemistry.
Theoretical chemistry is trying to understand processes in the world at a molecular level.
It's predicting the experiment before it's been done.
It's a blending of physics, mathematics, and chemistry.
We can make predictions about processes that we have never performed or never done measurements on. And this is needed for the next discovery that helps solve some of the big challenges in the world.
It is, for some of us, a wonderful way of life. Theory at Caltech began with Linus Pauling, who set a splendid example for all of us.
We're at a very interesting time where there's the intersection of both traditional physical simulations, paper and pencil theory, and artificial intelligence and big data, which is changing how we can formulate theories about the chemical world. So Caltech is preparing to be at front of this new era. The Marcus Center was founded as a place to house and promote theoretical chemistry and chemical engineering research. The center, we hope, will play an important role in this next century of discovery. One of the unique things about the Marcus Center is that it has substantial resources behind it, which will allow us to support a thriving and growing program of research by supporting fellowships and grants to support new exploratory directions in this area.
Jack and I both appreciate the power of good theory, a fundamentally good, important theory, how strong it can grow, how robust it can grow. So we hope this kind of theory can be generated from Marcus Center.
What I try to do in my research is try to create a bridge between what's happening at the atomic level in sustainable technologies like batteries and what's happening at the macroscopic or the device level to develop better batteries that can charge faster or store more energy, or other technologies like maybe water desalination systems which use less energy and are more cost effective. The theory and the simulation and the experiment all have to come together if we really want to understand a given system.
I'm a theoretical chemist working in electronic structure. If you give me a set of molecules with their geometry, I can go back and calculate what the energy of these molecules are. And as a person working in electronic structure, that's the basic ingredient that we provide to either other theorists or other experimentalists so they can understand better how these reactions are taking place.
One of the things that my group has worked on for many years is trying to understand the behavior of electrons, which are the sort of essential particles to make chemistry happen.
A lot of the techniques that you might use for quantum physics are now relevant for quantum chemistry, and also vice versa. So that's one of the reasons that Garnett's group in particular is very exciting.
It's very hard to do research just by yourself. You really need a good team of students and postdocs around you that help you drive the research, come up with ideas, and make progress. And the Marcus Center really has the potential to be the place where the best and the brightest come in.
Here at the Marcus Center, you're going to find the best professors and you're going to find the best peers that are all focused on pushing the boundaries of chemical theory.
The Marcus Center helped me identify the questions that is important for our scientific community and society. And it trained me to think rigorously and critically and produce high-quality research.
To have students and postdocs interact with each other who have different perspectives, different backgrounds, have a different way of approaching problems, and hopefully there'll be some synergism in how they get together, how they learn from each other, and that will lead to new ways to view chemistry and new ways to understand the behavior of the world around us.
I feel connected to the wider scientific community who work together to solve challenging problems.
I think it's a really unique opportunity to get to work through those problems side by side with somebody and get to bounce ideas off of each other, run your numbers against one another, and collaborate in more of a hands-on sense in the way that we're kind of working through these problems together.
And those are some of the most stimulating and exciting times as a researcher. You get to see someone else's perspective, maybe understand something you didn't understand.
I've seen how empowering this place has been to my graduate studies, and I'm excited to see this community grow and to attract more talented scientists and to study challenging problems together.
The Marcus Center will allow us to attract new talent and have visitors come, new students, new faculty come who can kind of contribute to this community. And so I think it'll be a sort of focal point for lots of different areas of theoretical chemistry.
It's going to be a force to try to pull us together to work jointly on projects so we can develop new and improved methods where you combine different kinds of phenomena. It should have a major impact.
We hope the Rudy Marcus Center will become one of the most important research centers in the world.
What I hope is that very soon, in a couple of years, when they think of theory, chemical theory, they'll think of Caltech Marcus Center.
I'm excited to write a new story of theoretical chemistry, continuing from the contributions of Rudy and all these other great scientists in the last century, a new story where Caltech plays an important and prominent role.